Hi, everyone. We are going to take some time to look at some examples of solving two-step equations. Okay. First, we need to go back and kind of discuss the order of operations. So the order of operations, when we discussed this previously, it was basically if you had an equation, it told you what to do first. So you would always do your parentheses first, then you would do your exponents, then you would multiply or divide, whichever came first, and then you would add or subtract, whichever came first as well. They were grouped together, addition, subtraction, and multiplication and division. To solve two-step equations, though, you want to use the reverse order of operations. So instead of starting with your parentheses, you're going to flip it around, and instead of PEMDAS, you're going to have SADMAP. Okay, and what SADMAP is telling you to do is you want to start with your subtraction and addition first. Then you want to do your multiplication or division, and then you want to do your exponents, and then last you're going to do the parentheses. Okay. Now, with SADMAP, an important thing to consider too is you want to start away from the variable. Okay, so let's say I'm just going to write this example up here. We've got 2x, let's say minus 2 is equal to 4. Okay, we would actually start with the subtraction here, the minus 2. We want to get rid of that first and be left with 2x is equal to whatever 4. And in this case, we would actually add 2, even though it says subtract, because we want to do that inverse operation. So we would add 2. So we would get 2x is equal to 6, and then we would solve from there. So you always want to start with whatever does not have that variable that you're trying to solve for. Okay. Another thing we got to look at is what are inverse operations? Okay. Inverse operations are going to be any operation that is opposite of the operation that you have that will actually undo it. Okay. So for instance, if you have addition, your inverse operation is subtraction. In this case, we have subtraction. So our inverse operation is going to be to add 2 to both sides. Okay. And whatever you do to one side, you have to do to the other. And when I say one side, I mean one side of the equal sign. So think of it this way. This is kind of your divider, and it's telling you that this 2x minus 2 is one side of the equal sign, and then 4 is on the other side of the equal sign. So anytime you're doing inverse operations on one side of the equal sign, you have to do it to the other. And the purpose is to cancel this minus 2. So if we have minus 2 plus 2, that's actually going to cancel and give us a 0. Anytime you have negative 2 and then you have positive 2, they're going to combine together, create 2 0 pairs, and cancel each other out. Okay. On the other side of the equal sign, though, we have 4 plus 2. And so that's actually going to combine to give us an answer of 6. Okay. And so then when we rewrite this, we would actually have, and I'm going to write this at the top, we would have 2x is equal to 6. And that's just showing you how to use inverse operations with addition and subtraction. Now, with multiplication and division is the same thing. If you have multiplication, your inverse is going to be to divide. And then if you have division, which an important thing to remember with division is if you have a fraction, a lot of times when we see two-step equations, we're going to see a fractions that's going to show us we have division. Okay, so you're going to use multiplication and division to undo each other. And so in this case, think about it this way. If we knew what the variable was, so if we knew what x is equal to, we would actually take this number in front 2 and multiply it by whatever that number is. So this is telling us that we have multiplication. So that means our inverse operation is going to be to divide. And when we divide, we want to divide whatever number is with this variable because we want to get the variable by itself is our main goal. So we're going to divide both sides by 2. 2 divided by 2 is just going to cancel. It's actually going to give us a 1. 2 divided by 2 is 1, which we could just write this as x equals. And then 6 divided by 2 will give us an answer of 3. A very basic two-step equation that shows us all of the steps that we have to remember when we're solving questions like these. Okay, let's take a look at an example of solving a two-step equation. And we're going to start with some more simple problems, and we're going to kind of increase the challenge level to kind of, practice and using these inverse operations and what we have to do to figure out what those variables are. So this first question is going to tell us that we need to solve for P. Okay, so we know that our variable is represented by P. That's the quantity that can change. Okay, and so we have this equation 3P plus 3 is equal to 6. Now I'm going to rewrite this over here. I'm going to have 3P plus 3 is equal to 6, just so it can give me some space. And I also want to go through and I'm going to label for you, why do they call it two-step equations? Okay, there's a specific reason why we refer to them as two-step equations. So in this case, we want to remember that we want to start away from the variable. So we're going to leave 3P alone for right now. We're going to look at this positive 3. Okay, this positive 3, we want to get to the other side of the equal sign, and I'm just going to draw my line right at the equal sign. We want to get the 3 to the other side. Okay, so in this case, we have addition, and so our inverse operation is going to be to subtract 3 from both sides. Okay, subtract 3. When you have a positive 3 minus 3, this is just going to come together and create 3 zero pairs, which are just going to cancel each other out. Okay, so this is going to leave us with 0. And then 6 minus 3 is going to leave us with an answer of 3. Now, this is where I'm going to label this as number 1. This is our first step that we completed, okay? The very first step that we completed. The next step that we're going to have, and I'm going to go ahead and rewrite this so that we have 3P is equal to 3. And I'm going to make my equal sign line again so that we can see each side, what we have to do. Now what we need to do is we need to look at what is with P. Okay, so we've got a 3 as the coefficient. And we know that if we knew what P was equal to, we would divide, or we would be multiplying 3 times that number. So in this case, the inverse operation is going to be to divide. Okay, since we know we're multiplying, the inverse is division. We're going to divide this number that is with P because our goal is to get P by itself. Okay, so we're going to divide both sides by 3. 3 divided by 3 is just going to cancel and leave us with 1. And then 3 over here divided by 3 is also going to leave us with 1. So we would actually say that our final answer is going to be P is equal to 1. Okay. Now we can go back, and I encourage you to go back and check your answers with these, because it's going to tell you before IXL or before if the answer is incorrect, it'll let you know, and then that way you could go back and you got to check. Maybe it was a simple math error. Maybe you put a subtraction sign instead of a addition sign, something like that. But that'll tell you that you go back and check and just see if there's something that happened. Now, we labeled this first half of the equation as a 1. This down here is going to be our second step. Okay. Now, very often you're going to have multi-step equations, okay? And that's going to have multiple steps that you're going to have to complete. So not all equations with variables are two-step equations, okay? We're just focusing today on two-step equations. So we're going to go back and we're going to plug this into the original equation here. Anywhere you see this variable P, instead of writing that variable, we're going to plug in the number that we found. So we have 3 times 1 plus 3 is equal to 6. So the only thing different from that original equation that I wrote is instead of writing P, I wrote 1. And we're going to multiply. 3 times 1 is 3, plus 3 is equal to 6. And then 3 plus 3 is equal to 6. And so we can see that this does check. And the purposes of checking it is you want to get the same number on both sides of that equal sign. That will tell you you have a true statement. 6 does equal 6, and so you can say that P is equal to 1. Okay, let's take a look at another example. This question is kind of written a little bit, it's written differently, but it's asking the same thing. Okay, so I'm going to go ahead and rewrite this over here. I'm going to say 2 plus 2b is equal to 4. Now, some of you are looking at this equation and you're saying, well, can I just rearrange it? The thing about rearranging it is you have to make sure you keep the sign with each of the terms. So in this case, the positive sign or the addition sign goes with the 2b. It tells you that 2b is actually a positive term. Okay, but we're just going to leave this alone as is, and I'll show you how to solve it. It's really simple. It's just written differently. So I'm going to draw my line at my equal sign. Okay, and I'm going to say, okay, the first thing I need to do, my first step is to subtract 2 from both sides because we want to do the number that is away from the variable. So this 2 is by itself. So we're going to start here. Then we get 2 minus 2. That's going to leave us with 0, cancel out. Then 4 minus 2 is equal to 2. And then we're going to bring this 2b down. Okay. Now it kind of looks a little bit better as far as the way it's written. Now we know that 2 times b, okay, would give us an answer of 2. So we're going to do the inverse and divide both sides by 2. 2 divided by 2 is just going to cancel, leave us with 1, or we can just write b. And then 2 divided by 2 is going to equal 1. Okay, and then if we go back through and we plug this into the equation to check, we could say, okay, 2, and we're going to put a 1 here. 2 times 1, and 2 times 1, I'll put parentheses, separate those. 2 times 1 is 2, so then we have 2 plus 2 does equal 4, and so we can see that this does check. Okay, all right. Couple more equations we have. So now this one we're solving for v, but we can see we have a lot of negative signs here, okay? And I'm going to rewrite this, negative 3v. Now, what I want you to pay close attention to is this plus a negative number. This is actually the same thing as just saying minus 11. Because what happens is you have a positive and a negative. So think about your multiplication rules. A negative times a negative is positive. Positive times a positive is a positive. But a negative times a positive is a negative. Okay, so that's going to be the same thing. We've got a positive and a negative. It's just, we can just rewrite it as a subtraction sign. These are the same questions. Okay, and then we have a negative 2. I'm going to write my my line for my equal sign, and then we're going to solve. Okay, we're going to start with the number that is away from the variable. So we're going to start with a negative 11. So we can see we have a subtraction problem, and the inverse of this is going to be to add. And we're going to add this number here. Okay, we want to add 11 to cancel it out. Whatever we do to one side of the equal sign, we have to do to the other. So add 11 to both sides. This will cancel. And then negative 2 plus 11. Okay, so this is where your rules for adding integers comes into play. Anytime you are taking a negative and adding a positive, or the signs are different is a better way to put it. You want to look at what is the bigger number. Okay, in this case, 11 is the bigger number. Then you want to find the difference between the two numbers. So 11 minus 2 is going to be 9. And then you want to keep the sign of the larger number. So in this case, the 11 was bigger. So the 11 was positive. So we're going to leave this as a positive. Okay. Another way to look at it is if you did the counters and you had 2 negative counters, and then we have 11 positive counters. 3, 4, 5, 6, 7, 8, 9, 10, and then 11. And then we want to make 0 pairs, so these would match up and these would match up, and then they would cancel, and then we would be left with 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8, 9. 9 positive counters. Okay. So then what we're going to do is we're just going to bring this negative 3v down. So negative 3v is equal to 9. And again, we would multiply if we knew what v was. So we would divide in this case, divide both sides by -3. And anytime you have a positive divided by a negative, your answer is going to be negative. And then we know 9 divided by 3 is 3. So our answer would be a negative, V is equal to -3. And then when we go back through and we plug this in to check our answer, we could say, okay, -3, and then I have a V, which I'm going to plug in -3 for that, plus, or we could just write this as a -11 is equal to -2. -3 times -3 is a +9 minus 11. Okay. And then we can change this to addition and change this to the opposite, add the opposite. And we would do the same thing we did before. 11 is the bigger number, so we're going to say 11 minus 9 is 2. And then since 11 in this case is a negative number, we would say that our answer would be -2. So we can see that this does check. This does give us the correct answer. All right. Let's take a look at these down here. These are going to have the fraction that I was talking about. Okay, so we were working a lot with that multiplication where we'd have a number and then the variable, and we know that we would multiply those. Now we have this variable over a number, which is telling us that if we knew what C was equal to, we would divide by 2. Okay, I'm going to show you this, the easiest way to remember these. And I know that fractions are not everybody's best friend, but hopefully after watching these examples, you'll be able to say that this is super easy and that that it's very, very simple, just like the multiplication. Okay, so I've got C over 2 minus 1 is equal to 1. And I'm going to do the same thing, same steps we did before, draw my line. Now, I'm going to start away from the variables. So since C is over 2, we're going to leave that alone for right now. We want to start with this -1, okay? Then we have a subtraction of 1, so we're subtracting 1. So the inverse is going to be to add 1 to both sides of the equal sign, okay? -1 plus 1 is going to cancel for us. And then we have +1 plus 1 is going to give us an answer of 2. That's our first step. Okay, now we're going to bring this fraction down. C over 2 is equal to 2. Now, we said before that anytime you have this fraction, you are showing that you have division. So we know that the inverse operation is going to be to multiply. Okay, so we're going to multiply both sides. Now, what it's important to remember that this number in front of C is a 1. So when we multiply, we want to cancel this out, we're going to multiply by what's called the reciprocal. And the reciprocal is you're just going to take this fraction that you have and you're going to flip it over. So instead of 2 being on the bottom, you're actually going to place 2 on top. And then 1, which was on top, you're going to place 1 on the bottom. We're not going to take the variable with us, though. We're going to leave the variable where it is because that's what we want to solve for. Okay, so we're going to leave the variable alone. So this is what you'd multiply this side by, and then you're going to come over here and you're going to multiply this side by the same thing. What this does is this is actually, you can draw an X through this. 1 times 1 is 1, 2 times 2 is 2, and it's just going to cancel. Okay. So we're going to bring down our variable here. Now, I know some of you are watching this and you're thinking, okay, I have a whole number, which is 2, and then I have this 2 over 1. How do I multiply a fraction by a whole number? You can actually say that this 2 over 1, or I'm sorry, this 2, this whole number of 2 is the same thing as 2 over 1. Okay, anytime you have a whole number, you can rewrite it as a fraction just by placing a 1 in the denominator. So in this case, we're going to just multiply across. 2 times 2 is equal to 4. And then 1 times 1 is equal to 1. 4 divided by 1 gives us an answer of +4. Okay. So then we can go back and we can check this by saying 4, if we place 4 in the and I'm going to change this so it's easier to see, 4 in the numerator. So 4 divided by 2 is going to be an answer of 2. 2 minus 1 will give us an answer of 1. This is going to tell us that that C equals 4 is going to be correct. Okay. I do want to look at a couple more with fractions just so we can practice what we kind of just went over, and we can see it in other examples as well. So let's take a look at these two. And I encourage you to kind of look at both of these and see if maybe you can solve them by yourself. And then as we're going through it, you can see, did I do all the steps correctly? Okay. So I'm going to start with this solving for f over here, and I'm going to rewrite this as f over 9. And then I have this minus a negative number. Now, I have a minus negative, so those double negatives are actually going to create a positive. Okay, so it's actually plus 26 is equal to 31. Now I can go through and I can draw my line at the equal sign. And then I can say, okay, the first thing I need to do is I need to look at getting this variable by itself. And since f is with 9, we're going to leave that alone. We're going to go through and we're going to say, okay, so we have a positive 26. So the inverse is going to be to subtract 26, which will cancel on that side. And then we've got 31 minus 26 over here, which is just going to be a positive 5. We can bring it down our f over 9. We're going to do the same thing we just did a minute ago. When we have this fraction, we know that this is division. So the inverse is going to be to multiply both sides by the reciprocal, which, as we stated, as we looked at before, the reciprocal is just going to be this fraction flipped over. So instead of 9 being on the bottom, it's going to be on the top, and then 1 is going to be on the bottom, and we're going to leave the variable alone. We're not going to bring the variable with us. We're going to do the same thing on this side, okay? So the purpose is to cancel this side, which this will cancel, and then over here, we want to figure out what f is equal to. Now, again, we have this fraction multiplied with this whole number. So we can go ahead and say 5 is actually going to be over 1. That's the same thing as 5. 5 divided by 1 is 5. And then we just multiply straight across. So 5 times 9 is 45. 1 times 1 is 1, but we know that 45 divided by 1 will give us 45. So our answer is f is equal to 45. You can check this too. We can plug this right into the question. So instead of f, we're going to rewrite this as 45. 45 divided by 9 is 5 plus 26 is going to be equal to 31. So we know that this is going to check for us. Okay. I'm going to erase this, give everyone a minute to kind of look at it, but I'm going to erase it so we can look at the other question, where we actually going to be solving for h in this case. And hopefully you tried this already, and maybe you could follow along and just check your steps and make sure that all of your steps were completed correctly. Okay, so looking at this, I'm going to rewrite this question here. So we're going to have negative 11 equals h over 4. And then I have a plus a negative. So remember before we talked about when we have a positive and a negative, it's actually going to create a negative, okay? So we're going to just rewrite this as minus 12. It's the same thing, same equations right here, minus 12 or plus a negative, okay? I'm going to draw my line. Now this equation is going to be different just because the variable's on the right side of the equal sign, not the left, but we're going to solve it the same way, okay? We're going to solve it the exact same way, whether it was on the right or the left. We want to get this variable by itself. That's the main goal. So the first step we're going to do is we're going to look at this minus 12. So the inverse operation is going to tell us that we need to add 12 to both sides to cancel this out on this side, leaving us with 0. And then we have a positive 12 and a negative 11. So this is where you use the rules of addition. You look at that bigger number, which is 12, and you say, okay, so 12, and really with the rules of addition, it's because the signs are different that we're doing it this way. So 12 minus 11 is a 1. And then since the 12 was the bigger number and it was positive, we would just leave the 1 as positive, okay? And then we have h over 4. And I'm going to rewrite this down here so we have some space to solve this. So h over 4. Now we have our fraction, so we know that this is division. So the inverse is going to be to multiply. And we're going to multiply by the reciprocal, which we know this is 1h. And we're going to leave the h, the variable, alone. So when we multiply by the reciprocal, we're just going to flip it over. It's going to actually be 4 over 1. 4 was on the bottom first, so we're going to put it on the top in the numerator. 1 was on the numerator, so it's not going to be in the denominator or on the bottom. And we're going to do that with both sides. And this is going to cancel, leaving us with just h. And over here, we could say that we multiply straight across. This can actually say 1 over 1. So 4 times 1 is 4. 1 times 1 is 1. 4 divided by 1 is 4. So we would say that our final answer for this question is going to be h is equal to 4. We could plug this in 2 to solve, make sure that it's correct. 4 divided by 4 is 1 plus a negative 12, which is going to be the rules for addition say that the signs are different. We have a positive and a negative number. So 12 minus 1 is 11. And then since the 12 was a negative number, the 11 will also be negative. All right, so this will check as well. All right, couple more questions. I think there's only about 2. There is one I want to take a look at because it has an additional step to it, okay? And this is where this 2-step equation, some of them are going to have multi-steps, okay? Now, we talked about using the distributive property. So we've got this number on the outside of the parentheses, and we have to distribute it in order to solve this question. So in this case, the 8 is on the outside. We're going to distribute this to both the C and then the negative 85. Everything in the parentheses is actually going to be multiplied by this number 8. And we will get an answer of 8C. If you take your calculator and you multiply, and we could also do this, you could do this without using calculator as well. We could say that 8 times 85 negative will give you a negative 680. So we would say this is going to be a negative 680. And then the 48 is going to stay the same. We don't have to distribute anything to the 48. It's on the other side of the equal sign. Now we're in a good setup right now where we can complete all the steps we've done before. There's just bigger numbers, but that's okay. Okay, so we've got this 8C. We're going to leave this one alone first because we want to get rid of the negative 680 first. And so since this is subtraction, the inverse is going to be to add 680. Okay, which is going to cancel. We're going to add 680 to the other side as well. And that's going to be, we've got 8 plus 0 is 8, 4 plus 8 is 12, and then this is going to be 728. So then we're going to bring down our 8C, and that's going to be our first step completed. And now we have this 8C, which this would tell us multiplication, so the inverse is going to be to divide both sides by 8, the number that is with the variable, leaving us with 728 divided by 8. It goes into 72 9 times. This is going to be 0. Bring down your 8. 8 goes into 8 1 time. And this is going to leave us with a remainder of 0. So C would be equal to an answer of 91. Okay, now you can go back through and you could check this. We could say 8, and then we've got 91 minus 85. And then this is equal to 48. And we want to do what's in this parentheses first. So 91 minus 85 would just give us an answer of 8 times 6. And 8 times 6 is 48. So this is going to check and give us a correct answer of C is equal to 91. All right. And then we have one last question that I want to take a look at. We want to solve for B in this case. Okay, so I'm going to rewrite this. This is one of those questions that's kind of written with the variable on the right hand side of the equal sign, which is okay. Okay, we could just leave it like this. Now we run into this positive and a negative, so we know that that's just going to give us a negative. And then we can draw our line and begin to solve. So this 38, it's minus 38, so the inverse is going to be to add 38 to both sides of the equal sign. Okay, 38. This is going to cancel for us. Now, in this case, you have your addition rules. You've got a negative and you've got a positive, okay? So we want to look at the bigger number, which is 86, and then you want to find the difference between 86 and 38, which is going to be an answer of 48. And since the 86 is the bigger number, this is going to be negative. And I also want to show you this on the calculator so you can see it, okay? So we've got a negative 86 right here, and we're adding 38. It's going to give us an answer of negative 48, okay? So now we have negative 48 is equal to 3b. So to get this b by itself, we would just divide both sides of the number that is with b. Okay, cancel this out. This is just 1 or b. And then negative 48 divided by 3 is going to give us a negative 16. Negative divided by a positive will give us a negative answer. And then you can also check 3 goes into 4 one time, 3 goes into 18 6 times, and you get negative 16. And then we can check this. We've got 3 times 16, negative 16, will give us an answer of negative 48 plus negative 38. And we can see that we have negative 48 plus 38 will give us an answer of negative 86. So this will check as well. Okay.